you all for standing by, and welcome to today's webinar, Managing VMware as Code and with HashiCorp Terraform. My name is Karen Wee. I'll be helping to facilitate today's webinar. Please feel free to type your questions in the Q&A section during the webinar. This webinar is recorded, and the recording will be made available after post-processing, usually within 2 days. Our speakers today are Grant Orchard, Senior Solutions Engineer with HashiCorp, and Nico Bluebear, Lead Cloud Solution Engineer with VMware. They'll be exploring a hands-on approach to building a GitOps workflow with Terraform Cloud and VMware Cloud on AWS. Please feel free to reach out directly to the speakers via Twitter for any follow-up questions as well. And now, let's get started, Grant.
Brilliant, thanks, Karen. All right, so as Karen said, you've got myself and Nico presenting today. So you can reach out to me on Twitter at Grant Orchard, easy enough to find. My blog also, which covers off different stuff around all HashiCorp basically, as well as some of my previous content and subject matter expertise in the VMware landscape. You can find that at grantorchard.com. Nico, would you like to introduce yourself?
Yeah, so hi everyone, I'm Nico Bluebear, I'm a lead cloud architect at VMware. Again, you can find me on Twitter at Nick972. And I've also got a blog with a ton of content around cloud and networking, automation, and lots of stuff around Terraform and VMware Cloud. So we're going to cover a ton of content today. We'll start with about 10 minutes of kind of slideware, a presentation around VMware Cloud on AWS, and Grant will cover Terraform Cloud and some of the concepts behind it. But we've mostly going to do lots of demos, live demos mostly. Everything will, as Karen said, everything will be recorded if you want to share later on or review. But we're going to use different tools like Terraform Cloud, HashiCorp Sentinel to deploy VMware infrastructure. So things like virtual machine, NSX networks, and NSX security rules, and an entire VMware Cloud and AWS data center, right? All done through code. So the first, let's talk about what we're going to build throughout the presentation. We're going to build a VMware Cloud environment. So what is VMware Cloud on AWS? So I'll just cover it in just a couple of minutes, but essentially, if I had to summarize it, it's VMware as a service, right? So what you get is at a click of a button or through an API call is an entire VMware environment running on top of AWS bare metal, right? So you get vSphere, but also NSX for virtual networking, vSAN for storage, and the vCenter to manage it all. And it's all fully automated. It takes about 90 minutes to deploy an environment. And because we leverage a pool of capacity and the elasticity of AWS, we can scale up and down in a matter of minutes. Again, it can be done automatically. We can add a new host to the environment and scale back down. And it's a service offered by VMware. So we take care of all the patching, management, monitoring, and our customers can just focus on running their applications on top of this managed offering. And it's totally compatible with your VMware environment, right? It's just a VMware environment, but running in somebody else's data center. You can link up the VMware Cloud vCenter with an on-prem vCenter and see the full inventory, whether your VMs are in the cloud or on-prem. And you can do vMotion to and from the cloud. You can leverage just a IPsec VPN tunnel to connect back to your data center, or even use a AWS Direct Connect if you have one. But it's not just a colo, essentially a service in the AWS colo. It's much more than this. We actually directly connected into AWS. And actually, when you deploy your VMware Cloud environment, you will link it up to your AWS account and to your AWS Virtual Private Cloud, a VPC. And we have a high throughput connection between VMware Cloud and native AWS services, which means you can start bringing applications, building hybrid applications between the VMware Cloud environments and services like RDS, S3, EC2, and others from AWS side. And that's really what we're going to be building shortly. Will be a hybrid application that leverages RDS in the backend, and the front end will be running on VMware Cloud. So what do we see our customers using VMware Cloud today? A lot of them are using VMware Cloud for disaster recovery or for test and dev. But the primary use case will be data center migration. And we have customers that instead of buying more team and deploying it themselves, just want to lift and shift their VMware infrastructure to the cloud, shut down the data center, and start modernizing their applications. So what we're going to build today is a totally secure hybrid cloud as code. So starting with using Terraform and multiple AWS providers to build a full infrastructure, right? So starting with the AWS provider to build a VPC and subnets, and we'll use it to build the VMware Cloud on AWS SDDC, right? Using the constructs in AWS that we created beforehand. Once we've done this, we've got an empty VMware Cloud environment, and we're going to start building network segments for our virtual machine. We're going to start building security rules for our VM. And finally, we're going to use the vSphere provider to actually deploy a virtual machine on top of it. But all of this done through code. There are actually more VMware providers, Terraform providers for VMware, including vRealize Automation, vCloud Director, but we're just going to focus on VMC, NSX-T, and vSphere today. And all of this will be deployed through Terraform Cloud.
Brilliant. Thanks for that roundup, Nico. So when we look at Terraform Cloud, I think it's really interesting for us to just go back and have a look at what Terraform is that most of us are probably used to, that CLI, that single binary that we just download. And if we look at the workflow that we actually use when we're using Terraform open source, we typically open up our IDE, we'll write out some code, maybe we'll go out to the public module registry to just use, some stuff that other people have already created to save ourselves some time. We'll, assuming we're doing things right, we'll do a bit of Terraform plan, then we'll jump into Terraform apply. And all of the infrastructure that you've described in that code then just, spits itself out into, whichever endpoints you've actually described. And you keep all of your code typically locally. Maybe you start to look at actually pushing that out into, either a local repository, local Git repository, or, potentially up into some other kind of version control system. But as we start to sort of scale this stuff out as an organization, and as you start to grow, we start to see that things get a bit more complex. And if we take a look at this diagram here, we see what Terraform Cloud, and specifically the Terraform Cloud business tier, starts to bring in for you as customers, is the ability to start mapping out things like, how do we do team structures? How do we create team structures within Terraform so that we can share infrastructure and information about our infrastructure between different teams? How do we centralize all of our code? What can we do in terms of addressing any of the regulatory requirements that we might actually have to work under as an organization, or the security and audit requirements of our cyber teams? How do we sort of wrap all of that up? So Terraform Cloud takes all of those concepts, basically dumps it on top of the workflow that you know and love around Terraform Plan, Terraform Apply, and just gives you that, I guess, safety scale without ever affecting the speed that you get out of Terraform. So let's dig a little bit into, one of those capabilities here and one of those complexities that I was sort of alluding to. And that's the idea of separation of duties and how we handle things like teams when it comes to Terraform Cloud. So on screen at the moment, what you'll see is kind of a simplified subset of teams that we're going to sort of talk around today, and the different responsibilities that they would typically have. So, VMware Cloud on AWS, the key is kind of in the name there. When you want to get started and deploying an SDDC, you're going to need some infrastructure to exist in AWS. So, what are you going to do? Are you going to, log a ticket against your AWS team and say, hey, we need a VPC, we need some subnets, we need some route tables. You're going to say, we need this stuff because we then need to, take our account IDs, that subnet information, and feed it through into our VMC config, as an example. You've got your NSX team, and they're really responsible for that idea of how do they apply consistent security policy, both against your on-premises VMware environment and your VMC environment through things like, policy groups and, distributed firewall capabilities that are embedded within NSX. You've got DBAs who, maybe they're working with RDS out on AWS and they need to know about things like VPCs as well that core team manages. Maybe they're also managing, internal SQL, Postgres, whatever it might be within your on-premises environment. And finally, you've got application teams who really want to basically just get the infrastructure out there that they need in order to, release their applications and release their code. And when we look at this interplay, it becomes pretty obvious that with the number of different layers, even within this simplified model that we've got here today, if you actually have to log a ticket against each team to say, hey, here are the things that I need, here are the resources that I need, and then as a result of you creating the resources, here's the information about those things that I actually need to build my stuff, it's just simply not going to scale. So the first thing that we want to look at doing here is saying, how can we take that interaction process between teams and those dependencies and apply the same kind of as code principles that we really advocate for here at HashiCorp? So let's with that just jump in. I'm going to start taking you through the UI. I'll take you through some code and we'll have a look at how we go about actually codifying those dependencies. All right, screen share coming right up. Good stuff. All right. That's not showing up on my little screen, but I don't have my media box up, so I'm hoping we're looking good over here. Yep, there we go. So what you can see on screen at the moment is my Terraform Cloud environment. I'm just going to zoom in a little bit to make that more readable. We did have some questions about whether these demos are going to be available after the fact. Definitely the recordings are. As I step through this, I'll show you where you can find the Terraform code that backs this within my GitHub account, and I'll allow Nico to do the same for his. So our starting point, as I said, is really this AWS team. So there's this core, what I've got here called a Terraform VMC AWS core is the name of that workspace. Now, this workspace maps to a backend repository where I've got the Terraform code that we'll have a look at momentarily to see how we go about describing all of these resources. What I wanted to show you here, you can see that I'm in as an admin user. We've got various, menus and things within here. But if we take a look at our Terraform state, we can see effectively all of the code or all of the outputs in effect and all of the detail and information and attributes of the resources that we've actually provisioned in here. Scrolling through this quickly, none of the actual information is all that relevant for us, with the exception of sort of, line 6 down to, it's probably about line 50. But really here, where we can see the outputs that we've described in the code. Now, the challenge that we have, of course, is how do we only allow access to the outputs for those different teams? Because, I don't know, Nico is managing the SDDC environment, but I don't necessarily want him knowing, too much about what's going on within this AWS environment. There's some sensitive information I don't necessarily want him to be seeing. So we need to find a way to handle that. So allow me to just show you really quickly. If I flip screens, you can see here that I'm in as my GO user, which is my HashiCorp account. If I flip screens here into another browser where I'm logged in as Grand Orchard, funnily enough, not GO, this is my personal Gmail account. I've been allocated access to only a couple of workspaces. So here we actually have an NSX workspace, And here's the same Terraform VMC AWS core workspace. And if I come in here and have a look, there's a number of menus that I don't actually see that I used to have access to under the previous account. If I go into the last run, I can actually come into the apply and I can see then the outputs, but I can't see any of the other state, which is great. So what this means is that really based on the role and the permissions that I'm given within a workspace, potentially I can only see the outputs that I'm going to be making use of. Again, when we spin up that VMC SDDC, we're going to have to feed through our account ID, which is here. We are going to have to map through subnet IDs and so on. Now, the sharp-eyed amongst you might notice that there's this view raw log button here, and you might be wondering, hey, if I click that, is that going to give me all the raw detail? Have you just sort of hidden it within the UI? Thankfully, the answer to that is actually no. You can see here that it's exactly the same content that we actually see in screen there. So just those outputs are available to me to use within my personal account or within the context of my personal account. So here we have our outputs, the information that I need to use, which is kind of halfway there. But we're not here to talk about infrastructure as a web console. We're here to talk about infrastructure as code. So what I'm going to take you through now is how we actually capture these outputs and use them within our Terraform code. All right, just waiting for that to refresh. There we go. Okay. Now, this here is, I'm within VS Code. You can't see it, or actually we can probably see it over here under the what's it called, the browser menu. Terraform AWS core, that's the same. That's basically, this is the code that maps to the repo, which is then backing that workspace as well as a few others. Now, if we look in here, we've got a main file, which is where I've described the majority of my code. I've also got this here outputs file. So first of all, I'm just showing you how I've gone about actually describing the outputs within my code. So VPC ID comes from my VPC module, and I'm just feeding out the VPC ID value. That same mechanism transposes throughout all the different things that I'm doing here. We just declare the name of the output that we actually want to use and assign a value to it, and that then becomes available. Now, if I switch in then to my, where are we? Okay, my Terraform VMC single node files instead. Now here you'll notice that I've got an additional Terraform file which I've called config.tf. And in here what I've done is make use of a special resource type here which is called Terraform remote state. And what this allows us to do is query, again, once again, it's in the name, kind of obvious, but we're querying the remote state of a set of Terraform code to then retrieve information about it or retrieve information from it so that we can use it. So I describe it here, I give the resource a name, I call it AWS core, I specify that we're using the remote backend, and I feed through the config, which is my Terraform Cloud organization, and the workspace name, which again you see here, Terraform VMC AWS core. That just maps through nicely. So the name of the resource again will be, when we refer to it, data.terraformremotestate.aws core. So let's go and have a look at how I've utilized that. Okay, I'm just going to close that browser to make this a little bit bigger on screen. So the very first thing you see here between lines 1 and 4 are basically the blocks where I've set up some local variables. And what I'm doing is saying, hey, AWS account number, I just want to make this easy in case I need to reuse it, right? I can refer to that very simply later on, is equal to then that resource. So data.terraformremotestate.aws core, and the specification here being then that I want to use the, can't talk and use my fingers at the same time, shift, right, here we go. So outputs account ID, and similarly outputs public subnets underneath it. And then when I want to use these, I just feed them into the other resources using that local variable name rather than having to use that protracted long string there. It just makes it a little bit more readable, a little bit less likely to fat finger and make a mistake. And then we've taken advantage of this same capability here within our subnet IDs, public subnets. The fact that I've pluralized that should help you to understand that we're actually returning a list or more than one. And so I've just referred to the first object in the array and said, hey, I want to drop that here as the customer subnet ID that we're going to link into our VMware Cloud on AWS account. All right, so really, really quickly, before we just go back to our presentation, I will jump into, just so that you can have a look at this if you want to. I'm not sure that's actually a site, github.com/GrantOrchard. If you come into my repositories, you'll be able to do a quick search. Anything that's got VMC in it has been used within this demo today. So the only thing that's actually missing, if you do a search for AWS-core or just search for core, you'll see then the code that's spinning out the VPCs and the subnets. Here's our VMC single node that I'm actually mucking around with today and all the code for that. So if you do want to actually delve into this yourself and have a look, you'll be able to find it relatively easily. All right, so let's just switch back over to our presentation. So what did I take you through there? Just again, really quickly, I've shown you how we can actually take that concept of team dependencies and the idea of being able to share information and metadata about different teams' infrastructure across multiple teams so that we can actually codify that dependency or the interdependencies that we have so that you can just basically push on really quickly and easily in terms of writing everything up as code. And the second thing that we looked at very, very quickly, but is a really key thing to understand here, is that with Terraform Cloud, we can lock down that state file and really control what it is that you see. So any of the sensitivity there is taken care of. It's just removed from the path of your regular user so it doesn't get out into the wild. All right, Nico, I think that's probably enough of an introduction here. Would you like to take us through deploying our first SDDC with Terraform?
Yeah, absolutely. So I'll start sharing my screen. Right, so hopefully you can see my Terraform cloud environment. So what we're going to start doing now is start actually deploying infrastructure through Terraform. So Grant show you how we linked different workspaces together and take output from one and use it as an output from the Terraform for AWS provider as an input for Terraform for VMware Cloud. So what we're actually going to deploy here using Terraform and the resource block is to build an SDDC, right? So in VMware Cloud, you don't need a lot of parameters. You need to specify in which region you're going to deploy your SDDC. It might be in London, in Australia, in Japan. We have a number of different regions where we offer the service. And that's pretty much it. You can specify the type of bare metal host on which you're going to deploy VMware Cloud, whether you're going to have a single availabilities or deployment or multi-AZ. And all this, that's the code which is linked to the workspace. So in here, in version control, you can see this is the code that we're going to deploy through Terraform, right? So if I want to do a Terraform plan and Terraform apply, it can be either done whenever somebody updates the code on GitHub, or it can be done manually through here. So if we do this here, we're going to run a Terraform plan. And just like any Terraform plan, we'll look into the existing configuration, we'll look at the state, and we'll assess whether to deploy, to add, to change, or to destroy resource. So in this case, what Terraform is going to do is create an SDDC. So we're just going to go confirm. And now we go, let's go on the VMware Cloud console where we're going to see the SDDC being spun up. Now you can see this banner just popped up. An SDDC is being removed. Let's refresh. And you can see that a VMware Cloud environment is being built again through code live. Now, here I'm cheating a little bit because in real life, it would take about an hour and a half to build the full VMware infrastructure. So here we're using simulation of the APIs to prove that it all works. But in real, like I said, this one was it would take about an hour and a half, and we don't have that much time in our webinar. But this is one where we've deployed through Terraform, and if you look at it, it's a one host SDDC. Comes with onboarded 10 terabytes of NVMe all-flash storage and 512 gig of RAM. And you won't be surprised to find that it's pretty much like any other vCenter you've ever seen. Right? It's just running the nice HTML5 clients, and it's actually running vSphere 7.0. So it's running the latest and greatest VMware software, and because we, VMware, take care of all the patching and monitoring and upgrades, we're pretty much always running the latest software. And as I mentioned, we're running on top of AWS. It's EC2. It's not nested virtualization. It's actually running on bare metal, right? EC2 bare metal. And here we go. We've got our one node up and running, all built through code, but it's ready for us to start deploying virtual machine security rules, which we'll do shortly. But first, Grant, you wanted to talk about some of the policies around deploying Terraform resources.
Yeah, that's probably a good idea. Let me just jump straight into sharing, I think.
I'll stop sharing mine as well.
Come on, we can do it. Here we go, media players coming up. Bang, all right, there we go. Yeah, so look, Nico's been sort of taking us through some of the capabilities that we have really around VMC. And I think one of the challenges that we often hear customers asking us about is, if we just hand out self-service and things like infrastructure as code, broadly across our organization, especially when we're looking at things like public cloud services or anything where you sort of pay by the metric, pay by the minute or pay by the capacity or usage or whatever, are we going to find ourselves in a position where we basically made ourselves really, really fast, but we've just blown our costs completely out of the water? Are we going to find ourselves in a situation where we're at risk because we've got people instantiating infrastructure that maybe is deployed in an unsafe configuration? We've seen an awful lot of organizations leaking customer data, and that could be something and oversimplifying, but this could be something as simple as deploying an S3 bucket with public access rather than restricting that and making it a private access configuration. So what people asked us for was, how can we actually take these policies? How can we actually describe those as code? How do we make sure that while we're moving at speed, while we're trying to be agile as an organization, how do we keep ourselves safe? So if we take this maybe down into some specific details around something like VMC, let's just have a look at the code. And you'll see that there are a couple of things in here that I haven't actually specified as variables because I wanted you to be able to see them relatively easily. Now, as a point in case, for this particular webinar, when we actually spin up environments on VMC on AWS, it is actually using real hardware on AWS. So as a result, somebody has to pay AWS money for that, which in this case, thank you very much, Nico, and your marketing team. It's actually VMware who's footing the bill. So what they asked was, look, we don't want to basically blow our entire quarter's budget on a single webinar here. So can you please just use a one node SDDC, right? By default, you're going to spin this up with, what is it, Nico, 3 or 4?
You can actually go all the way back down to 2 now.
Right. So basically, we just wanted to put a structure in place that said, hey, yeah, we're only going to spin up a single node. Now, what if I was to, try and be a little bit sneaky here, right? And I say, look, Nico, I hear what you're saying, but, we want to show the power of a fully operational VMC environment. So what I'm going to do is change that from being a single node just back to the default, and it'll spin up whatever. Or in fact, I'll just delete that altogether, and it will just default to its default value. Now, how do we make sure in that case that things don't actually go wrong? And how do you stop me from actually doing that? Now, what I'm going to do is flip over here, and you'll see once again I'm still here within my Terraform VMC single node local repository. I'm just going to do a git add main.tf. We'll drop in a commit message. Set SDDC type the default. I remove the attribute. That's probably not the most accurate message. And then I'm just going to do a git push. Now, just one thing to call out here, you can see that I'm working within my development branch, trying to be a little bit responsible and not actually push directly into main. That is going to write up, which is good. Come back over to my browser here. And now what I should see is if I come into a branch, here we go, my development branch has just been updated 24 seconds ago. All right, so that's some good news. I'm going to make a pull request, and I'm just going to say, stuff you, Nico. All right, and we're going to create that pull request. So you'll note here what's going on now. When we actually register a repository into a Terraform Cloud workspace, what happens is that it basically injects some smarts in there to say, hey, what should we be doing before we just allow this code to come in and to run our Terraform plan and our Terraform apply? So we register basically a couple of checks. Now, one of those is what we call a speculative plan, right? So that is basically a Terraform plan that you can't actually say, hey, I want to apply what just happened there. So it's just speculative, happening in the background to see, almost like a unit test. Is this actually going to, come up in the way that we're anticipating, and is everything good? So that's the first check that goes on. The second thing that occurs here, I'll just zoom in a little bit further just to make sure we can see it nice and clearly, but we see that Sentinel has actually kicked in as well, and we've had a policy check that's failed, hard mandatory. Now, I can go and look at the details of that and see what's happened. So we evaluated two policies, and it seems that SDDC type has a value null, right? Because I deleted the attribute. So it's not equal to one node, which was what we say our permitted policy is, and we'll have a look at that policy momentarily. And so as a result, this has failed. And I think, the really cool thing to note here is we haven't even reached actually trying to execute this within Terraform yet. At this point in time, look, I'm an administrator, so I can override this and I could choose to merge it. But I could actually have the branch protection policy set up within GitHub to say, no, even administrators have to adhere to this. But what we're doing here is just, protecting you. So that whole process of, is this code safe for me to actually merge and then execute, we're really trying to inform that decision process for you and tie into those native workflows like you would for standard software development. All right, so let's actually take a look at that Sentinel policy. All right, so on screen right now, you can see here a set of code. I'm just going to zoom in a little bit more on that. And you can see here that we're pulling in a couple of different policies. Now, the one that tricked us up there was called, validate SDDC type. So let's just go and have a look at what that says. Now, I'm doing an import here. I'm importing our TF plan functions. So something that's important to know about Sentinel is, again, that speculative plan basically generates a whole heap of data. It computes values. It looks at your input variables. It looks at computed values. It looks at, well, being attacked by moths. It looks at the different resources type, the providers, effectively all of your Terraform code and all of what it's intending to do is there for us to look at and evaluate. So we're doing an import there, and we're just calling it plan, so it's simple to type out again. And we're saying here, permitted SDDC type in this case, and we can put in lists. We can put in more than one value, so it's not just a simple match. I'm going off to take a look at that plan, and I'm finding all of the VMC SDDC resources. And then we're performing a filter to say, hey, what I want to do is go have a look and call a function that's called filter attributes not in list. We're going to pass in all SDDCs as an argument. We're going to pass in the attribute that we're looking for, and we're going to look at the values that we actually want to match. This true on the end here is part of that built-in function. We'll just print a message, which is what you saw on screen earlier, if we actually have a violating condition match. And then we've got the main rule that we actually evaluate. So we could have many functions in here, and then at the end of it we say, okay, what is the rule that we want to evaluate? And in this case, what we're looking for is that the length of the violating SDDC messages is equal to 0. So if we had one violating, it's going to fail. If we had 2, 3, so on and so forth. This is just basically a Boolean check. Is it true? Is it false? And so we write things up in that kind of way. Now, this is not the only way that I could choose to spend more money under this VMC and AWS account. What else could I do? Let's come in here back to my code, and let's do this. Start typing this out. And just a quick note, so this is actually the official Terraform plugin for VS Code, which is really nice, right, and gives us some great capabilities to actually sort of query the provider, query the resources, understand the schema, and give us all of this IntelliSense capability in here. So I could actually spin up another VMC cluster. I could set the instance type. I can map it through to the SDDC ID, which would, in this case, let's do our interpolation here just so we can see what that's going to look like. Where are we? Oh. Let's see, underscore SDDC dot this dot ID, and I could then do a, what was it, numhost? Numhost equals 32. Now, there's a couple of other mandatory fields that I haven't actually included here, but you can see, by doing this, I'm basically bypassing that whole attribute down here, and I'm going to spin up another 32 hosts. So that's a problem. But once again, if we take a look at the Sentinel code that we've got written up, and I'll get out of that policy and go into the other one that we've got written. The other one that we're doing a check for are the permitted resource types. So again, VMC SDDC being a type, VMC underscore cluster being another type. As you work through the different resources, they're all available, and we've got quite a lot of capability to do those. So every single object then becomes a first-class object that we need to manage. So what I'm doing here is just saying, look, the only things that you should be allowed to bring through as a resource, not a data source, that's a different special type. The only thing you should be able to create and manage is a resource of type VMC SDDC. Now, I won't perform the commit there and try and feed that in. The plan would fail, first of all, because I don't have all of the required attributes within that resource, but this Sentinel policy would pick it up in the exact same way. Now, if you're feeling clever and saying to me, hey, Grant, look, couldn't we just use account? There are many other ways that we could get around this. And the truth is, yes, absolutely. So these policies are really just to give you a taste of the kind of capabilities that you can introduce with Sentinel to provide policy as code around everything that you're doing with your Terraform automation. If you were to do this in production, yes, you'd want to build something a lot more comprehensive in terms of validating exactly what's going on within your code and wrapping that up to make sure it all gets evaluated properly. You'd write tests, you'd make sure that it worked before you actually release this into production. But at the end of the day, I think this is a really, really nice capability. And if we take a look back here at what we just kind of learned and what we've gone through here, I think the two things that really stand out for me, well, that's what we learned about VMC and AWS. Yeah. Let's come back to this slide over here. All right. So Sentinel, again, this concept of how do we codify everything? How do we do everything as code with Terraform? So we're taking, in this case, it was probably more, technical policies, but we could include things like change windows or HTTP queries out to other business systems and feed those in as evaluation points as well. And secondly, that nice tie-in to your branch protection within your version control system. That integration into version control systems with Terraform with Terraform Cloud is really neat. It's really powerful. It's a lot more skin deep than just saying, oh, this is where we're going to store our code and, the end. So with that, we've got 18 minutes left. Nico, do you reckon you can get something deployed actually onto the VMC environment in that time?
Let's do this. Let's see.
Over to you.
So, one of the things that we can also use the Sentinel with is to enforce the way we write security policies, right? And I'm just going to share my screen. There we go. Now that what we're going to do now is deploy our security rules on VMware Cloud. Again, that's using NSX, which is a virtual networking and security platform provided by VMware. Now, again, if you had a user who maybe by mistake created a rule which allow any traffic into the SDDC, you might not want to do that. So you could create Sentinel rules to prevent the user from creating the wrong kind of security rules. So these Sentinel policies can be used for different use cases, right? This could be used for to control costs, to prevent grant from wasting the VMware marketing budget, and also from to enforce well-architected design policy and security policies. So we created a VMware Cloud environment, but it's empty, right? There's no VM, there's no firewall rules apart from some of the default security rules. Here, when we deploy the SDDC, we have one network, but we might want to deploy more networks, and then once these networks are deployed, we'll attach our VM to these networks. So again, going back to Terraform Cloud, and we're using this configuration. Again, we're using the NSX-T provider to create NSX-T entities within VMware Cloud. We're going to create network segments, right? One is going to be called segment 12. We're going to create policy groups, which is essentially a group that is part of the security rule. So what we're going to do is create a rule based on the name of the VM and based on the operating system. So if my VM is called is an Ubuntu and is also called Photo, has the name Photo in it, it will be dynamically added to the group. And then we have security policies, which is here, based on that group, which will be dynamically applied to the VM. So what we're doing here is we're creating security rules beforehand, and as soon as we deploy the VM in the later part of the demo, that will be automatically secured by by these rules. So let's go ahead and queue that plan. And what you find is, again, what we did beforehand is we linked that workspace with a GitHub repo where we push our code. We haven't put any of the secure variables on GitHub, right? So instead, we've got them here, and you can see here what's sensitive is the value of my token, right? That's a value I don't want to share. And Grant, even if he has access to that workspace, wouldn't be able to see it, right? It's something hidden from him. So we've done a Terraform plan. We're going to add 13 NSX resources to my SDDC, and let's confirm apply. Now we're about to deploy all the resources with Terraform. So we're creating policy groups We're creating network segments, and all of this is done. Right, so let's go back to our SDDC. You can see SDDC was pretty much empty, and now we've added 3 networks. A couple of them have DHCP enabled, some of them are just static networks. We've created groups. So as mentioned before, we've created security groups, which are part of security rules that we're applying. Now, right now, because there is no VM, it's a bit irrelevant. But as soon as VMs are pushed, they will be picked up by the security rule. So let's move straight to the next stage, which is actually deploying the virtual machine. So here again, we're using the Terraform for vSphere provider, and it's pretty. The good thing with Terraform and the way things are written is you can pretty much understand it from the way from the language. So what do I need to push a VM into vSphere? Well, I need to know the IP address of the FQDN of the vSphere server. I need to know the user and password, the username and password. And I need to specify in which data center I'm going to deploy, which cluster, data store, resource. So in this instance, what we're doing is we are cloning from an existing template. But what we could also do is deploy from a remote OVA or OVF and deploy it in the SDDC. So the resource we're going to be creating is a vSphere VM. It's going to be called Terraform Photo. It's going to be in the workloads folder. And it's going to be attached to that network 13, which is a network we've just created through Terraform for NSX-T. And I'm giving that VM an IP address. So if we go back to Terraform, we'll have to go to a different workspace. And this one here. So again, we're running a Terraform plan. So we're putting out information about our vCenter, and we're going to be creating this VM, right? So let's go ahead and do that. And if we go back into our vCenter, we should see an app, a VM being deployed from the template. Here we go. So you can see this happening live. Now, what's interesting about this specific application is it's actually the front end of a 2-tier app. The back end is actually on AWS RDS, and the front end is on VMware Cloud. And what we've done is we've allocated public IP to that VM, and that VM is actually accessible over the internet. So this VM here, that's our application. Backend is on RDS, and it's connected to this instance running in native AWS, deployed through Terraform. So we've built an entire hybrid application through Terraform, one half on native AWS connected over a 25 gig link to VMware Cloud, and the front end is running in the vSphere world, which is here. And if we go back to our security configuration, what's interesting here is the rules that we applied before are automatically applied to the VM we've created, right? Again, because we created a group which was based on the name of the VM and the operating system, and there's a match, right? So we've applied that security policies to this Terraform Photo application. So this, as soon as a VM is deployed, it's automatically secured by NSX. So here we go. Wow, I told you it was possible, Grant. we went through it quickly, but we've done it. Deploy a fully hybrid application into through Terraform.
Well done. So look, we've got a few questions coming through, Nico, which I would think it'd just be good to sort of delve into a little bit. So we've got one here from John where he's talking about the NSX-T provider. And he's just asking about whether or not we need to actually perform an import before you can actually manage some of those objects. Is that something you'd like to take?
Yeah, it's a great point. So, for VMware Cloud, when we use Terraform, we deploy. So, using VMC, we deploy NSX-T edge routers, right? So we get two edge gateway. One is a compute gateway, one is a management gateway, and they're deployed by Terraform for VMC essentially, or Terraform or manually. Now, what you have to do today when you use Terraform for an NSX-T provider is get this NSX-T edge gateway under Terraform control. So the first step, what you have to do is import them and take these resources under Terraform control before you can add resources. Now, what we are, the NSX team at VMware is building the provider, and they are going to release an addition to import it as a data source in the coming weeks. So you won't have to use the import, but you'll be able to use a data source to take this NSX-T edge gateway under control. Okay.
Great, thanks, Nico. So we've got a couple of questions regarding the code. So we've got a few people who want to be able to try this out and it looks like take it for a spin themselves. So shall we start at the beginning and we'll just walk through the different repos. I'm just going to share my screen and I might, if it's all right, Nico, I'll pull yours up off the Terraform Cloud workspaces. All right. I'm just waiting for that to go live with the screen share. Okay, that looks like that is coming up. Okay, so as a starting point, and apologies to those who were on at the beginning and we went through this, but we'll just go through it a little bit more slowly this time. So in terms of just setting up the AWS core infrastructure that was leveraged by the VMC provider, you can go and take a look here. In fact, so again, for most of these things, if you just do a search against my account on GitHub, you will find anything that has VMC in it was purely for today's session. So I don't actually have access to VMC day in, day out. So anything with VMC is going to be purely from today's session. So Terraform AWS Core is the first one. I use that actually for all of my AWS infrastructure, not just for VMC. Then we had Terraform VMC single dash node. So if you want to be instantiating, again, a single node, what I will say is, look, this code is very much fine for you to play with and mess around with. I didn't try and turn this into production grade Terraform code. It is like good quality for a demo, but it will need some work if you're actually going to try and use this within production, but definitely you can go in and play with it. The one thing to note is that throughout the things that I've done here, and if you missed the beginning of the webinar, I am making use of the fact that I have Terraform Cloud and sharing information between those various workspaces in play. So anywhere that you see data, Terraform, remote state, AWS core being used within that main.tf file, you may just need to either put those in as variables yourself or do perform your own linkage if you're actually going to use Terraform Cloud. Yeah, however you want to handle that, but just something to be aware of. Just go looking for those. That's that. The other thing that I showed that's in my repo is going to be Sentinel-VMC. So this is just where the code specifically lives for that Sentinel policy set that I've imported into Terraform Cloud, if you want to have a look at that. If we go across to Nico.
And no, it's NV there.
Yeah, it's not Nico. Yeah. My bad. If we come to Nico's repositories, so we've got the NSX-T work that he was doing there. And again, look, what I would say is you can find both of us on Twitter. I'll bring our handles up at the end. Very happy to interact, and we can do some more stuff around this. We can go into some more detail with you if you want to dig into it at all. So there's the Terraform Cloud, repositories. The VM, which is probably not a super exciting one to look at. Here's the VMC code that Nico wrote to spin up the Zero Cloud. You'll notice it looks very, very similar to the stuff that was in my repo as well. So all of this is definitely available for you to pull down and have a look at. Have any questions come through while I've just rabbited on for the last?
Yeah, I guess there were some questions around from Harish about plans for a HCX Terraform provider. And just briefly, HCX is our migration tool, what most of our customers are using to lift and shift VMware estate to the cloud. I believe there is an experimental HCX Terraform provider available. But I can check to see the current status. Again, if you connect with me, maybe through Twitter or LinkedIn, and we can follow up around this.
Perfect. So I'm seeing one here, which is that the Terraform import for SDDC is not clean, as it shows changes required for the imported resources. So look, what I would say there, this is probably something that we could dig into, and it looks like you may be local to Australia, so you can ping me directly again. So go@hashicorp.com. We can delve into this a little bit more. But normally what we see with imports is that there's going to be a lot of optional attributes that are going to be set up within that you've used within the UI that aren't necessarily in your Terraform code. So when you actually do an import and then you say, hey, I want to do a Terraform plan, because you haven't specified those in your code, they're going to show up as a change that's going to occur, and therefore there's an awful lot of things that are going to trigger a deletion and recreation of the SDDC. So we can definitely spend some time and work through that together if you'd like to. And I'm sure Nico, as much as the time zone's a bit of a challenge, he'd probably be happy to. Nico actually has colleagues in his team local to Australia as well, who we can probably tap to help us out with that. All right, we're at 6:59. We're at 6:59. Boom, look at that. All right. I'm just going to flip onto our last slide. So look, first of all, thank you everybody for taking the time here. I know we had some challenges with the time zone trying to support, all of Asia Pacific and Japan, as well as, the breadth of Europe. But I think we've done pretty well. Now, if you do actually want to learn more, Nico, in fact, actually has a VMworld session. When is that, Nico?
So VMworld is next week, and it's free. If you want to join and watch, we're doing a deep dive with my colleague Gilles, all around a similar concept around deploying VMware through Terraform. So you're very welcome to watch it and connect with us afterwards.
Brilliant. And we've both got our blogs there where I'm sure we'll see more collaborative work coming out. This is an area where we've got some really strong joint customers and some really strong interest in this. So, I expect to see a bit more of this flowing through. All right, Karen, over to you.
Thanks, Grant, and thank you, Nico. And thank you, of course, to our audience. That was a great session. And I hope everyone enjoyed today's webinar and has a better understanding of how to manage your entire VM infrastructure as code with HashiCorp Terraform. And finally, as mentioned at the beginning, this webinar was recorded, and we will make the recording available after processing. I will send a link to everyone who registered after this webinar. Have a great day. Bye, everyone.